right, let's do valency. Definition. Valency is the combining power of an element. Valency is simply the combining power of an element. Full stop. Yes, power. Valency is simply the combining power of power per se of an element. Full stop. Are we there? Valency is what? Combining what? The power of what? An element. Abi? Full stop. Full stop. For an atom to be stable, it must be either duplex or octet configuration. For an atom to be stable, it must be duplex or octet configuration. Are we there? Comma. By duplex configuration, are we there? By duplex configuration, we mean it must have two valence electron. By duplex configuration, we mean it must have two valence what there? Electron. Are we there? By octet configuration, we mean it must have 8 valence electron. I said for an atom to be stable, it must be either what there? Duplex or octet configuration. I said by duplex, it must have what there? 2 valence electron. By octet, it must have what there? 8 valence what there? Electron. Full stop. Please, question, please. Look up. Question. What are valence electron? Yes, must have 2. Like, we said, for atom to be stable, it's not atom are stable now. It's not even stable. For it to be stable, it is in 2 conditions. Either what? Duplex or what? Octet what? Configuration. So if I say configuration, what do I mean? If I say configuration, what do I mean? If I say configuration, what do I mean? The what? Put down. Configuration is simply the perhaps look up. Wait. No, we said it will have either duplex or what? Octet what? Configuration abi. I said by duplex it will have what? 2 what? Valence electron. So here's the question: what are valence electron now? That's the question I want to ask. Not what? What I asked you earlier now. No, not that one. I've given that one before now. What are valence electron? Abi? Yes. It will have what? 2 valence and what? 2 valence and what there? 8 valence what there? Electron. What are valence electron? Valence electron are simply the electron at the outermost shell of an atom. Valence electron are simply the electron present in the outermost shell of an atom. Valence electron are simply the electron present in the outermost shell of an atom. What do I mean? Look up. Let me say for sodium, we had what? 2, 8, and what? And 1, abi, is 11. Is it complete? Yes, 11, abi. So it's complete this way, abi. This last shade you are seeing is called what? Valence electron. So now, question, here's it. Sodium, is it stable? Yes or no? No. Why? Because we said it must be either what? Duplex or what? Octet what? Configuration. It will have either 2 valence electron or what? Or 8. Here is 1. It's not stable. So that's why sodium is always Na plus. The oxygen number of sodium is Na plus. You should know this stuff. Na is plus, H is plus, abi Cl is minus. You should know those stuff, like their oxygen number. We call it oxygen number. You should know them. So why is sodium Na plus? Because this plus means what? Losing, abi. Why is it losing? It will lose what? This one. So it become what? 8-2 stable. So if you don't lose this one now, it means what? 8. That's octet for it to be stable. That's like the concept behind valency, right? So I'm saying that it's simply what? The combined power of what? An element, abi. So we said initially, give me an example that we use initially. We use what? Number one, we use what? And what? Sodium, abi. That's Na. That's K, abi. And what? Chlorine, abi. Basically, chlorine is what? Cl minus. Na is plus, abi. N is plus, abi. What of potassium? 2 plus, abi. 2 plus, abi. That's 2 plus, abi. Now let's see, here's the concept. Hydrogen is having H plus. What does it mean? It means what? It will what? It will what? Lose that what? One electron, because itself is just one electron. It's not stable. Either you what? Add one to it or what? Give that one out. Are you there? Either you collect one outside to make it 2 to be stable, or you what? Give out that one electron outside. Chlorine is what? 17, abi. How many electrons outside there? You know, we said the combination is what? 2, 8, 8, 1, abi. 7, abi. Okay, for chlorine 7, abi. 2 like 8. Okay, 287, abi. Sorry, 287 is chlorine, abi, as we did earlier, abi. For this chlorine now, is it stable? This is the last shell, abi. Is it stable? It's not stable. It must be either duplet or what? Octet configuration. So this one is just 1. It's not 2, it's not 8, it's not stable. Chlorine is having 7, like outside shell. It's not stable yet. The question is what? Either 2 or 8. Now, for chlorine to be stable, is either we will do two things. Either what? Add 1 to it to make it 8. Or give out what? No, or give out, what's it called? 5 out and what? Have 2 left. Like it's in 2 cases. Either this 7, we add 1 to become 8. And or we give out what? 5 and what? Keep 2 to become stable. In the two children, the easiest one to add 1 to it to make it 8 is the easiest one than what? Taking 5 away from it. That's why you have what? Minus, gaining. How many electrons there? Just 1. That's the concept of all this stuff. This is what? Losing what? 2 what? Electron. What's the atomic number? 2881. 2 what there? 2881, abi. This position, abi. Yes. So what is it K2 plus or K plus? It's K plus. It should be K plus. It should be just a K plus. I will say after the class, I'll send you guys all these elements and their position number. You should know them very well. So for this one now, this is plus means what? Losing 1 electron, abi. So it will lose this one now is not stable. Yes. It's not stable here. Stability is in age of 2 things. Either what? 2 or 8. Yes, what? Just 1. So either I add 1 to the what? I what? Give out the 1. Yeah, what they do, they give out the 1. So that becomes what? The 8 now stable. That's like the concept behind valency. That's the concept, please. So you should know, if I seen Cl minus, you know why it's minus. If I seen Na plus, you know why it's plus. That's all, please. Let's look at let's define ion. What are ions? What are ions? Let's define ion. You can't think that at this level now you're just saying the word ion. What are ions? Put down. These are atom or radical. Ions are group of atom or radical that contain a charge, either positive or negative. Radical are atom or group of atom, or if you want to, radical that contain what? A charge, either what? Positive of what? Positive of what? Negative, Abi. What's positive? What does it mean?
Lose.
Is losing what? Electron, Abi. Negative is what? Gaining what? The electron. That's your ion definition. Let's look at radical. Let's look at the concept of radical. Let's look at radical. Put down. These are group of atom. Radical can be defined as a group of atom, are you there? Yes. That act as a single unit. Radical is simply a group of atom that act as a what? A single. Look up. Is H plus radical? Wait. This is H plus, this is H plus. This is what? Ion. Are we there? Either this, or if I have NH4 plus, this is what? Ammonium. This is what? An ion. See why? Because having charge. Whenever an element or a compound is having charge, because of the ion. Are you there? Look at this. If I have H, if I have H2, if I have H plus, let's say this is A, this B, this C. What does it? What does A mean? What does A mean? What's B? What's C? You can tell me.
H is an element.
H is what? Atom, Abi. An atom. This atom. What's on there? Molecule. Diatomic. Yes. This is what? The molecule.
H plus
Ion. So ion. You should know this stuff. Ion. Very important, please. Ion. So when it comes to radical, basically, it is not just an atom, but what? A group of what? Atom combined as one to form what? Something, Abi. Example is H2O. H2O, the water. This is one hydrogen. Sorry, two hydrogen, Abi. Combined with what? Oxygen to give what? The water. This is what? A radical. What is radical? Because what? I'm having what? More than one element, one atom combined to what? Form what? A compound. If I have NH3, this is what? The ammonia. This is ammonium, right? This is ammonia. This is what? A radical. Why? Because I'm having nitrogen combined with what? 3 what? Molecules of what? Hydrogen. This is radical, please. If I have CO3, CO3 is still what? The radical. Carbonate, right? So this is like radical. So let's look at, so yeah, the major reason why I'm teaching you radical and valency is that I want to teach you how to write compound. If I say write lead 2 3095, you should not write it. Can you do that?
What?
If I say write lead 2 3095, you should not do that. I'll show you how to do that very soon. Don't worry, I'll show you how to do that. All right, at this point now, we're done with radical, Abi. So Benny, please, let me give you some popular radical. So Benny, please, some popular radical. Are you there? And their valency is given below. Some popular radical and their valency is given below. Some popular radical and their what? Valency, what have you? It's going below. Number 1, this one I want to give you, they're very, very important. They come out very well in JAMB. So let me give you, instead of giving you all of them, let me just give you the most important one that come out. Number 1, let's start with what? Ammonium. That's what the NH4 plus. Valence is what? +1. Number 2, hydroxide. That's HO, right? OH per se. OH minus, that's -1 is the valency. Are we there? Number 3, we have trioxonitrate 5. Let me just make it clearer. We have trioxonitrate 5. That's NO3 minus. That's what the minus 1 is the valency. Number 4, we have diazonitrate 3. What's the valence? What's the formula there? That's NO2 minus 1 is the valency. Number 5, we have triazocarbonates per se. We have triazocarbonate. What? 4. CO3 2 minus. This minus 2 is the valency. Number 6, we have hydrogen triazocarbonate. Has what? HCO3 minus. This is minus 1 as the valency. Right? Number 7, we have tetraoxosulfate 6. This is what? Is it? This is IV now.
N to H and so.
Yeah, like is this 6? This is IV.
No.
VI, sorry, per se. VI, abi? So that becomes what there? Tetraoxosulfate SO4. Tetra is 4, right? Tri is 3. Tetra is 4. Penta is 5, abi? Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. Deca is 10, abi? Undeca 11. Dodeca 12. Trideca is 13. Follow that French, what's it called? Stuff like that. This one is called minus 2 is the ion. Minus 2. Finally, let me just give finally one last one. 8. Tri per se. Let me give you trioxosulfate 4. That's what? XO3 2 minus 2. These are what? Simply examples of what? Some important radical you need to know. Please know them. We use this stuff in naming compound, please. How to write compound. Use them in writing compounds. All right. What because what I written here? Huh? Yes. This is trioxosulfate 4. All right. By the way, are we done? Huh?
Yes.
All right. Now listen. Let me explain something, please. Why is it that? Look up. Why is that I'm having 2 minus, not minus 2?
2 minus.
Yes. Why is I'm having 2 minus? Why is it not minus 2? Fine. Minus 2 means what? Is what? Gaining 2 electron, abi?
Yes.
2 minus is still means what? Gaining what? 2 electron, abi? Why is it not minus 2? Why is it not minus 2? Why is it minus 2? But why is it 2 minus, not minus 2? Here's the concept. Pick out any sciences at random. Pick out any what? Science as what? At random, abi? Let's say I have O minus 2, abi? Come, what's it called? Mathematician, a math professor. What he's saying here, he's saying indices. He's saying what? 1 over 0 to power 2. A math is saying this. Co-chemist. A chemist, what are you saying? He's saying what? Oxygen gaining what there? 2 electron. That is saying. So this same word mean two different things from what? Two different scientists. So to now avoid the confusion, you know what? You swap it this way. Instead of minus 2, because of the 2, that's chemistry. So I'm saying 2 minus 2 is no longer mass again, is what? Chemistry. That's the concept, please. Very important. So if you're saying 2 minus 2 is math. If you're saying what? 2 minus is what? Is not chemistry. That's why this stuff is very important, please. So these are your radical. All right. From here now, we look at how to name compound using what? The concept of what? Radical. Subheading, please. Subheading. At this point, subheading. Naming compound using the concept of valency. Subheading, please. Naming compound using the concept of what? Valency. Are we there? Put down. Two elements can only combine if they are of opposite charges. I said two elements can what? Only combine if they are of what? Opposite charges. Two elements can only combine if they are of what? Opposite what the charges, Abi? This means that atoms with the same charge do not readily combine. This means that atoms with what the same charge do not what? Do not readily what? Combine. Full stop. Do not readily combine. Okay, I can say do not combine. 1, 2. Are we there? All right. So we said atom or perhaps two elements can only combine if they are what? Of what? Opposite what the charges. Are we there? So the combination, put down. The combination of two elements with opposite charges. The combination of two elements with what? Opposite charges. Okay, is illustrated below. I said what? The combination of what? Of what?
Opposite charges. Two elements with opposite charges.
Is given what there below. Okay, put this down, please. Copy this down. Let's say I have element X combining with what? Y. We said, look up. For these two stuff to combine, there was a bit of what? Opposite what? Charge Abi. Let's say here is A. Here should be what? Minus B. They can combine this way, right? So copy this down. Now under this place, under here, write that when two elements are combining, under this place here, when two elements are combining, they exchange their power, ignoring the sign. When two elements are combining, they exchange their power, ignoring the sign. They exchange their power, ignoring what the sign. Look up. These two stuff want to combine. What's the first principle? They must be what? Of what? Opposite what? Charges. One is what? Plus another is what? But if it's possible, they can't combine. If it's plus, they can't what? Can't combine. So now you said what they do there? They what? Exchange what? Their power. Look up. This one will come here. This one what? Go here. I'll have X what? To power what? B. Abi. This part, yes, you said ignore the sign. I said that they exchange and what? Ignore what? The sign. So X here is X here, Abi. This B comes here. What next? Y. Here comes what there? I'll have A. This is how to write compound. This. So they exchange their power and what they ignore the sign. Example, 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 example. If I have, look up, if I have sodium Na plus, Abi, combining with what? Chlorine Cl minus. Please, can this combine? Why? They have what? Opposite charges. Right? Now we said when they combine, not just one here, Abi, they what? Switch, Abi. That becomes Na to 1 here. Abi? Then what? Cl. It's called what? Sodium chloride. This is how the formula is derived. Like this is how it was gotten. Let's say I have hydrogen H plus, Abi, plus what? Oxygen is what? 2 minus. Abi? Let's see what this will form for us, please. We said 2 comes here, Abi. That becomes what there? H2. 1 come, Abi. Is what? Water. This is how it works. This is how it works. Right? At this point here, note something, please. Under this, note something. Note something. Are you there? Note something, please. When two elements are combining, such that they have opposite charge but the same number, such that they have opposite what? Charge but what? The same number. Are we there? After their combination, the numbers cancels out. The numbers cancel out. Example under what I just said now. Look up. If I have calcium, Ca 2 plus, Abi, is 2 plus. Calcium is 2 plus. Combining with oxygen, what? They have opposite charge, but what? The same what? The same number. All happen. We said what? At the end, number what? Cancels out, Abi. Yes. What am I expecting here? This to come here, Abi. Yes. Like Ca what? 2 and what? O2. They are the same. They what? Cancel out. All I'm having left, CaO. Which called what there? Calcium dioxide. This calcium dioxide, please. Calcium dioxide. I'll be teaching you when we go higher in chemistry. I'll teach you how to name compound. If you see NaOH, what do you call it? How do you name it? Sodium hydroxide. Abi?
Sodium hydroxide.
No problem. I'll teach you how to name, like I'll use the concept of oxidation number to teach you those stuffs, right? So let's just proceed with this. Are we here? Let's look at something else. Some compound, put on at this point here, some compound has varying oxidation number. Some compound have varying what? Oxidation number. But one, lead. That's Pb2 plus or Pb3 plus. Number 2, copper. Copper is what? Is it C or Cu? Cu plus or what there? Cu3 plus. Now listen, just on that thing. What do you call it in English language? Lead. Abi? What do you call it chemistry? Lead. English and what? Chemist. Bro, that problem again. If you're in English class, call this one there lead. Chemistry, call it there lead. That's the concept of all the scientists and their problem, right? So note that lead Pb can be either what? +2 or what? -2 +3, and copper can either be what there? +2 or +3. Very important. Example under this example. Are we there? Write lead 2 triazonitrate 5 4 per se. Write lead 2. Write lead 2. Are you there? Lead. Yes, now yes. Lead 2 trioxonitrate. What's it called? 4. It's 4. It's 5. It's 5. It's 5, please. It's 5. It's V. Check it, please. It's 5. It's V. 5. Trioxonitrate 5. This is in word, Abi. Please let me write out the compound. How do you do that? Only B in formula in this form. Only B. I said lead 2, Abi. It's quite simple. Just check. It's very easy. I'll give you a work to do now, and you tell me my answer. Yeah. I said write what there. Lead 2. Please, for lead 2, that become what? Pb2 plus. Abi. Combine with what? Triosonitrate 5. Check radical. I gave you that what there? NO3 minus. This is very important. For you to write any compound, you need to know this thing. So what's triosonitrate 5? Yeah, I have what there? NO3 what? Minus. Can they combine? Yes. Why? Plus and minus, they can combine. The opposite charges, Abi. Yes. Now, please, when these two combine, what happen? These two comes here, Abi. Yes. This one goes here, Abi. That become what there? PB. Observe, there's a 1 here. That one will come here. So then they're putting 1 here again. Are you there? Said this. Observe. This one will come here, and there's a 1 here already, Abi. That one come here. This one what goes here, Abi. Now, mind you, I will not come and say NO3 because I said 2 should be here. Now you have to put 2 here. This is 2 is wrong. What do you now do? You what encase this one what in a bracket and put what there? 2 here. This is called what there? Lead 2 triosonitrate what? 5. Is it here? So if you see this, you should know how you call it. This is called lead 2 triosonitrate 5. Let's do one more example on our half, please. Let's do one more example on our half. Are we there? Example 2. Example 2. Are we there? Limestone used in making cement. Limestone used in making cement is got from the combination of limestone used in making cement is got from the combination of what? Of calcium and triocarbonate 4. Calcium and trioxocarbonate what there? 4. Write out the formula for limestone. Write out the formula for limestone. Full stop. Write out the formula for limestone. Yeah. What am I having there? What am I focusing on?
Write limestone used in making cement is got from the combination of
calcium outside first plus what? Triazo what? Carbonate. Check your radical. Try what there? What is it there? Triazocarbonate. That what there? No. No. This is wait oh. Okay, this triazocarbonate here. CO3 2 minus. So that becomes what?
Calcium Ca.
Okay, do it first. Let me see. Do try it. All the answer. Just try it. Let me see. Just try it out. Before I do this for you, try it. Yes, try it. Try it first. Let me see what all you get as the answer. They exchange their power, Abi, ignoring what? The sign. If you observe, in that case is a case of this nature. You're having the same power. At the end, it's what? It cancel out. Ca what there? CO3. That's correct. Look up. I have calcium, Abi. 2 plus Abi. Combine is what? Triazocarbonate, Abi. CO3. 2 what? These 2 comes here, Abi. become Ca2, Abi. These two go to become what there? CO3, 2. Set in bracket this way. They are of the same what? Number, as I said earlier there. What happened? They will cancel out. What my final answer there? CO, CO3A. This is called what there? Calcium thiocarbonate what? 4. Formula for limestone. It's very important. That's it, please. Let me give some assignment to try. Assignment to try. All right. This JAMB question says, so this is 2002. This JAMB question says, it said, A is an element. A, assignment number 1 says, A is an element with atomic number 11. Please, what's the element?
Atomic
Number 11. Sodium.
Yes.
A is an element with atomic number what there? 11. And B is an element with atomic number 17. That's what there? Chlorine. So, without even solving, what am I expecting? Sodium chloride. This small. Imagine, I've done it already. So just put it down. It says A is an element with atomic number 11. Are we there? And B is an element with atomic number 17. Full stop. If A and B react to form a compound, if A and B react to form a compound, comma, what is the formula of the compound? What is the formula of the compound? Are we there? It says, question 2 says, what is the formula of an oxide? What is the what? Formula of what? An oxide, that's oxygen, right? In which the valency of nitrogen is +5. In which the valency of nitrogen is +5. Question number 3, right?
In which the valency
of nitrogen is +5. Like just +5. Are we there? Question number what now? 3. It says element X has 2 electrons. Element X, capital X, like element X has 2 electrons. Are you there? In its outer shell. Please, if I ask you, which element has 2 electrons in outer shell?
element.
Which element has 2 electrons in its outermost shell or outer shell? Calcium. 2882.
Oh.
That last 2 is outermost shell. It's calcium. Think fast. The question says element X, or perhaps an element X, has 2 electrons in its outermost shell. Are we there? While electron Y has 6. Why electron Y has 6? Question: which electron has 6 electrons outside? Which electron? Oxygen. Yes, 2 6. 2 6. That's the concept. While element Y has what? 6. Full stop. What is the formula of the compound formed by X and Y? What is the formula of the compound formed by X and Y? What is the formula formed by the What is the formula of the compound formed by what? X and Y. Let come again.
Yes.
Which part there? I said element X, Abby, has 2 electrons in its outermost shell, while element Y has 6, Abby.
Yes.
What is the formula of the compound? What is the formula of the compound formed by X and Y? Formed by X and Y. So that's like all for today's class. So here's a key stuff to note. Basically, I just say that great teachers do not make great students, right? So you make yourself great by my instructions. So here's the thing here. After class, aside this one I gave you, go online, check questions, right? Search for it and then I'll help. So remind me, I'll send you the element with their what? Oxygen number.
Oxygen number.
Please remind me. So you should know them very well. They're very important. So that's like how. So next class, look at the concept of number of particle in an element or a ion. Next class. All right.